Okay, so what I'm going to do is show you the balanced equation that this little set of problems that we're doing is going to be based on. And if you look at your homework and turn to page 574, you'll see it's kind of like 11 ABC and 12 ABC, because I'm going to do several problems. Um, First of all, on concentration, which is what number 11 does, and then three problems in your homework on uh, changes in volume. Okay, or changes in volume are going to be the stress. So there's stress and there's what LeChat does. So let's go ahead and look at what happens if we increase the amount of hydrogen. The way we write that is like this. And if you haven't already done so, would you please be sure you write down external in the stress column, because LeChat has nothing to do with the stress other than his reaction. Okay? And what LeChat wants, that's what he does with the reaction. He accomplishes with the reaction. What is he actually accomplishing? Okay? So, this column is always a no-brainer. H2, what do you think, folks? LeChat wants to do the opposite. Is the amount of hydrogen going to go up or down when LeChat gets into the act? It's going to go down, for sure, just like in the animation. All right? So, what does LeChat actually do with the reaction? Okay? He reduces H2 concentration. This is the quickest and easiest way for you to write concentration. So, if he's going to reduce the concentration or the amount of hydrogen, which way does he have to shift? Okay, how many think it's to the right? Oh, come on, be brave. Raise your hands. Okay, the rest of you think it's left? Or you don't know? Okay, I only got 6 or 7 hands. So if you're feeling uncomfortable at home about answering this, you're in good company. So, at any rate, we are trying to talk about what happens with this guy right here. That's the balanced equation that we're working with. So, if I want more of the H2, I've got to go opposite of what it's doing, what it would normally do. Because what it normally does is these two guys come together. Okay? Actually, that would be the most common thing. So, at any rate, these two guys would come together and hydrogen would go away, wouldn't it? So, it's what shift? To reduce the hydrogen? It's a right shift. Yeah. As you can see, it's very little writing. Okay? And I made it that way intentionally, so you could understand how to get to what they're asking you to find. Now, let's do this differently and make it with water. And let's do the same direction. I'm going to add water to the liquid. Okay, I'm going to add a pure liquid to a solution. Pure liquid is water. The solution is water and carbon monoxide and hydrogen are making CH4 and H2O. So we've got all of those guys in the reaction vessel because this is a reversible reaction. So I'm going to add H2 after we get to equilibrium. Or H2O, I'm sorry. I'm going to add the H2O. So what does LeChat want to do? Huh? Down. Okay. So he wants to reduce the H2O concentration. All right? And when I reduce the H2O concentration, which way do I shift? Yeah. The reason I did an increase for both hydrogen and water is to point out how important it is for you to look at the balanced equation and see where those guys are. Because to reduce them, we've got to go to the side opposite. So with water being increased and LeChat wanting to decrease it, we're going to be shifting to the left, of course. Okay, that will reduce the water. On the other hand, when we were here, we had to shift to the right to reduce the hydrogen. How am I doing? Making sense? Okay. Let's go down and do the next one. And to do those two, I'm going to move this guy down to here so we can still see it. And let's get rid of this little circle. And let's deal with volume. Volume is different. I'm going to do a demonstration with the class, and this demonstration will be using a balloon. Okay? So, unfortunately, you can't see it at home. I'll tell you about it after we're done. If you want to do this demonstration at home, get yourself a little balloon, fill it full of air, and then step on it. As you can tell at home, if you did what I did, you will be able to wake up a class of sleeping students by doing this demonstration. So, as I mentioned to the class while I was doing this, you all know that when you squeeze a balloon, it gets harder and harder to squeeze it more because the pressure is up and it's resisting you. Okay? And if you force the issue by stepping on it, you're making the container too small to be able to stay in one piece. And it doesn't stay in one piece because of the pressure. So when the volume is up, the pressure goes down. But when the volume goes down, which is what I demonstrated, the pressure gets to be too great and it explodes. So what do we know about the pressure when the volume goes up? What happens to pressure? See, here's where with volume problems, you put in pressure. So what's the pressure doing? Volume's up, pressure is down. No. Volume goes up, you're making a bigger container, and this is not anything like a balloon because you can't do that with a balloon. Okay? But when the volume goes up, pressure goes down. Now, what does LeChat want to do? Pressure what? Pressure up. Now with volume problems, it's a whole different ball game. Okay, each of the three problem types is very, very different in how you figure out the shift. So for this particular shift, what you do is you count the molecules. How many molecules are on the left in the balanced equation? 4. Okay, so we got 4 over here. How many molecules are on the left? 2. 1 for each because there's no coefficients. We assume them to be 1. And so we have 4 on the left and 2 on the right, and we are ready to answer the question. LeChat wants to shift. This is your reason for pressure and volume problems. Shift to side with what? What do you think? More or fewer? Fewer will not bring the pressure up. Yeah, you gotta shift to the side with more because that will make more pressure. When I first blowed up, when I first blew up the balloon, I was adding I was adding more particles, and I was doing the thing of 4 versus 2. It was like starting out with 2 and going to 4. The balloon got bigger, right? And that made it have more pressure. Okay, so the pressure goes up when you increase. And so your shift is going to be to the left. Yeah. All right. Now we do the balloon. Here we go. Pressure is what? The stress is? Volume went down. What happened to the pressure? It went up. You know it went up. Okay, first-hand experience. So LeChat, again, wants to do the opposite. Pressure down. All right. And he's going to shift to the side with more moles here to increase the pressure. Left that out, sorry. And now we shift S-H-I-F. Oh, I did have the T in. Okay. With more, with more particles. Okay, and here we're shifting. There's where I wanted my T. Shift to side with less or fewer particles. Because the particles could be atoms or molecules, right? Like we did with the equilibrium constant, K equilibrium. And so to get the pressure down, we got to shift where? To the right. Yeah, pretty obvious now, isn't it? Oops. R-I-G-H-T-T. Emphasize that. Yes. Okay. What do you think, folks? Is this a little more understandable? Does this help? Yeah? Okay. I hope this is helping you at home. I'm going to go back to the animations now, and let's look at them with new eyes. Okay? Here we go. I'm going back. I'm going to add more of this stuff.
In this case,
Up.
the stress applied to the
No, you don't want to listen to that. So, now, what's going to happen? This guy went down. When it went down, this also went down, and this guy went up. So we could see the color change. We could see the numbers changing, and everything works according to the way we wanted it to, because we had to put these two guys together to make this, which used up the SCN and the FE. And as these got used up, this guy was created, the FESCN. Okay? And likewise, if we take out one of the products, which in this case is going to be the iron, watch the iron disappear. Okay? Now, LeChat's at work, and the iron came back, but not all the way. Right? Remember, I left my pointer in the same place, and it was covered completely before we started. And then, I'm sorry, after we, yeah. Anyway, where we started. Yes, that was where we started. So again, see, we started up here. We removed the iron. And that made this guy go up, because the only way to get more iron is to break up this guy. We see that this gets broken up. We make one of these and one of these. So each of these went back up 1, 2. Yeah, 2. And we saw the difference over here in the color of the solution. And with the volume now, did I show you volume earlier on this animation? Volume change? Did we do that this period? Okay, let's do that. Watch an increase in pressure. To increase the pressure, that's the external stress. LeChat can't do that. Okay, and look at your little sheet that we just did, and try to visualize what this is. which side has more moles? The left or the right? The right. See the coefficient? There's no coefficient for I2. Yes. If they're equal, that's such a good question. I'm so glad you asked that, meaning. And the simple answer is LeChat can't do anything because all he can do is shift left or shift right. But no matter what he does, he can't go left or right because it's useless. You get the same number of moles either way, right? And I think one of your problems is like that. Yeah. So let's go and increase the pressure. So down goes the plunger, and now LeChat wants to decrease. So which side should he go to? Should he go to the I2, which has a coefficient of 1, or the I that has a coefficient of 2? He went to the I2 because it has a coefficient of 1. The I had a coefficient of 2. See? There's your 2. This guy has a 1 as a coefficient. The subscript is 2, meaning that there's 2 iodines in the molecule. All molecules of gas take up the same space. I know that sounds weird, because some gas molecules have as many as 20 or 30 atoms. That's a lot. Okay, but it doesn't take up any more space than hydrogen, H2. They all take up the same amount of space. Isn't that weird? Okay, let's go back and let's make a decrease in pressure. We're going to shove that thing up or pull it up. The pressure just went down. Which side has more atoms? What? Okay, which side has more atoms? Or particles, I should say. Has it shifted yet? There it goes. See? Went to the side with more coefficient. Bigger coefficient. That's it, folks. I hope this really helps. Bye-bye. See that?